Jupiter is becoming a massive, unstable beast on the verge of detonation. Betelgeuse, one of the most noticeable stars in the universe, emits more energy than a billion suns. Known as a red giant star, it is so large that, if placed in the sun's position, it would reach the orbit of Jupiter. This immense, erratic object is ready to explode. When we think of stars, we typically imagine small, twinkling lights in the night sky, which is how we see them from Earth. However, stars are far more complex, and one of the most remarkable stars, Betelgeuse, is much larger and more fascinating than our own Sunday. Betelgeuse has baffled astronomers for years, and recent developments, especially from the James Webb Space Telescope, have revealed even more troubling information. The star's unpredictable behavior has left scientists increasingly concerned. In this video, we explore the magnificent new findings about Betelgeuse, its impending destruction, and the impact this will have on the universe and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a massive wonder, a colossal star that has intrigued astronomers for centuries. The Greek astronomer Antonius first discovered it. It is so enormous that it can be seen from Earth, especially during the winter months. If you're interested in cosmology, you've probably heard of or seen this star, which marks the upper left shoulder of the Orion constellation. Betelgeuse is an aging star and one of the most marvelous stars in the night sky. However, Betelgeuse's brilliance is far from stable. It fluctuates in brightness, which is one of the star's defining characteristics. This change is something we must examine further. Most of the stars we see are located far away from Earth, with the closest star being about 4.2 light-years away. To understand light years, imagine traveling at the speed of light for an entire year. Light moves at a speed of 186,000 miles per second, and in a year it covers billions of miles. So when we say a star is 4.2 light-years away, we're talking about a distance that is billions of miles from Earth. Betelgeuse is much farther, located around 600 light-years away. Even at the speed of light, it would take 600 years to reach it, a time frame far beyond our current technological capabilities. Despite this immense distance, Betelgeuse shines incredibly brightly in our sky. Its immense size is the reason it can still be so visible despite the distance. Betelgeuse is about 10 to 20 times more massive than the Sun, and its radius is many times larger. However, when viewed through telescopes, it appears as a disk rather than a small point of light. Unlike other stars, this is likely due to the reactions taking place in its outer layers. As for its mass, Betelgeuse is estimated to weigh between 12 and 19 solar masses. A solar mass is the standard unit used to measure the mass of stars, and one solar mass is roughly equivalent to 2 times 10 to the power of 30 kg. Since Betelgeuse lacks any companion stars or planetary bodies orbiting around it, scientists can't determine its exact mass, but it's clear that it is far heavier than our Sun. Betelgeuse's brilliance is another key characteristic. Its luminosity ranges from magnitude 0 to plus 1.6, with magnitude 0 being 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be many times more luminous than our Sun. This variability in brightness is due to the star's throbs or pulsations, where Betelgeuse expands and contracts. When it expands, it gets brighter, and when it contracts, it dims. These throbs can last anywhere from 10 to 100 days, contributing to the star's dynamic appearance in the night sky. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. These spots are areas where the magnetic field is stronger than in the surrounding regions, and they interfere with the flow of hot gas to the star's outer surface, making these areas cooler. This phenomenon helps explain why Betelgeuse is cooler than our Sun despite its massive size and brilliance. The spots on Betelgeuse are much larger and more numerous than those on the Sun. In fact, the spots on Betelgeuse can be twice the size of Earth. Betelgeuse also has a magnetic field many times stronger than the Sun's, which causes the gases in its outer layers to swirl or bend. When viewed through a telescope, the star has a surface temperature of about 3,500 K, which contributes to its weak red color. Betelgeuse wasn't always a red star. Around 100,000 years ago, it was yellowish, much like our Sun. Over time, it began changing color, shifting from orange to red. Around 10,000 years ago, it transitioned into the red star we see today. This gradual color shift suggests that Betelgeuse is evolving. Despite its enormous size, Betelgeuse is not the largest star we know of. Its mass is between 12 and 19 times that of the Sun, and even at the lower end of this estimate, it remains a colossal celestial body. Betelgeuse's fluctuating brilliance and dynamic nature are the results of its ongoing throbs. These pulsations, driven by internal cycles, cause the star to expand and contract, altering its brightness. When it expands, Betelgeuse becomes brighter, and when it contracts, it dims. This variability in brightness contributes to the star's dramatic and fluctuating appearance in the night sky. Betelgeuse's surface temperature, relatively low for such a large star, further defines its red color, a hallmark of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is nearing the end of its life. It has exhausted the hydrogen fuel in its core and is now fusing heavier elements such as helium and carbon. This fusion process produces energy and causes the star to expand. The star's atmosphere is filled with complex physical phenomena, including dark magnetic spots, which prevent the convection of heat, leading to cooler areas on its surface. Despite these cooler spots, Betelgeuse remains an enormous and brilliant star, but it is ultimately destined for a dramatic and spectacular end. When it runs out of fuel, Betelgeuse will undergo an extreme fusion process, turning even heavier elements like carbon and oxygen. This process will cause Betelgeuse to expand to much larger sizes, making it one of the largest stars in the night sky. Eventually, it will die in a massive explosion known as a supernova, marking the end of a massive star's life. The force of this explosion will be so powerful that it could dominate an entire star system. It might even send shock waves through space. While this event is not imminent, scientists are closely monitoring Betelgeuse's behavior as it approaches the end of its life. The star is expected to eventually go supernova, a deadly event that will release its outer layers into space, leaving behind a dense core. Depending on its mass, this core could either become a neutron star or collapse further into a black hole. A supernova is a destructive event in a star's life cycle, signaling the final stages of its evolution. Given Betelgeuse's enormous brightness and relative proximity, its supernova could be visible from Earth without a telescope. This explosion will release vast amounts of energy, creating heavy elements like iron and nickel, which are crucial for the formation of planets and other celestial bodies. These elements will be scattered across the universe, enriching the interstellar medium and contributing to the creation of future generations of stars and planets. In recent years, scientists have observed unusual changes in Betelgeuse's brightness, leading to speculation that the star might be nearing the edge of a supernova. Despite these fluctuations, it's difficult to predict exactly when the explosion will occur. Some scientists believe Betelgeuse could go supernova within the next 100,000 years, which, in the grand scheme of the universe, is a short period, but still too far off to pinpoint with precision. The James Webb Space Telescope, JWST, has provided new insights into Betelgeuse's behavior. The telescope's infrared capabilities have allowed scientists to study the star's outer layers and magnetic fields in unprecedented detail. These findings have confirmed the star's ongoing changes, including its irregular brightness and potential instability. This data offers valuable information about the processes leading to a star's death, providing a better understanding of stellar evolution. Betelgeuse's eventual demise will have significant implications for the universe. The shock wave from its supernova could potentially trigger the formation of new stars in the surrounding region, continuing the cycle of stellar birth and death. Furthermore, the elements produced by the explosion will spread throughout space, contributing to the formation of new planetary systems. In the broader context of astronomical evolution, Betelgeuse's death will not only mark the end of one of the largest stars visible to us, but also pave the way for the creation of new celestial objects. Although we won't be around to witness Betelgeuse's final moments, studying the star provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on Betelgeuse helps astronomers better understand the processes that govern the birth, life, and death of stars. It also offers a glimpse into the fate of other stars with similar characteristics. As technology advances, Scientists hope to continue studying Betelgeuse with cutting-edge tools and space observatories. The data gathered from Betelgeuse will shape our understanding of astronomy, helping us unlock the mysteries of stellar evolution and the forces at work in space. Betelgeuse, as a massive and dynamic star, is a key piece of the cosmic puzzle. Its eventual demise will be one of the most captivating events in the history of the universe. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing. New stars are being born every day, and the energy released by supernovae like Betelgeuse's will ensure the cycle of life and death continues. The legacy of Betelgeuse will live on, not just in the elements it creates, but also in the knowledge it has provided to generations of astronomers. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe, learning more about the forces that shape space and our place within it. Through these cosmic giants, we are reminded of the vastness and complexity of space and the remarkable cycles that govern the universe we call home. Betelgeuse, one of the most fascinating stars in the universe, has been a subject of intense study for astronomers, not only because of its enormous size but also due to its erratic behavior and its critical role in understanding stellar evolution. As a red giant, Betelgeuse is a star nearing the end of its life cycle. Like all stars, it follows a predictable pattern of birth, life, and death, but the details of that process remain shrouded in mystery, especially when it comes to massive stars like Betelgeuse. The study of red giants like Betelgeuse provides essential insights into how the most massive stars evolve and die. As these stars run out of hydrogen in their cores, they begin to fuse heavier elements like helium, carbon, and oxygen, leading to the star's expansion. This expansion causes the star to become many times larger than it originally was, sometimes making it so large that it becomes the dominant object in its star system. In Betelgeuse's case, the star's outer layers are unstable, constantly expanding and contracting in response to the internal processes occurring within. These pulsations contribute to the star's fluctuating brightness, giving it an unpredictable and dynamic appearance in the sky. This variability is a common trait among dying stars, particularly red giants. The eventual supernova of a star like Betelgeuse also has profound implications for the surrounding region. When a star undergoes a supernova explosion, it releases an incredible amount of energy that can have a significant impact on the nearby interstellar medium. The shock waves from this explosion can compress nearby gas clouds, triggering the formation of new stars in the process known as triggered star formation. This process plays a vital role in the ongoing cycle of star birth and death. By contributing to the creation of new stars, a supernova ensures that the cosmic cycle continues, enriching the universe with new celestial bodies. In addition to triggering star formation, supernovae also contribute to the creation of heavy elements such as gold, platinum, and uranium, elements that are crucial not only for the development of planets but also for life itself. These heavy elements are scattered across the galaxy, enriching the interstellar medium and providing the building blocks for future generations of stars and planets. This ongoing cycle is fundamental to the way the universe evolves. By studying the behavior of stars like Betelgeuse, scientists can better understand the processes that govern the creation of these elements and their role in the broader cosmic ecosystem. The death of a star, such as Betelgeuse, marks a key moment in the life cycle of the universe, one that will continue to shape the formation of galaxies, planetary systems, and even life itself. Furthermore, as astronomers study the end stages of massive stars, they also gain a better understanding of the potential future of our own Sunday. While our sun is much smaller than Betelgeuse and won't reach the same dramatic size, it will eventually undergo a similar process, though on a much slower timescale. The sun, like Betelgeuse, will expand into a red giant as it exhausts its hydrogen fuel, eventually shedding its outer layers into space. However, because our sun is not massive enough, it will not end in a supernova. Instead, it will shed its outer layers, creating a planetary nebula, and leave behind a white dwarf at its core. This process, though different from a supernova, is part of the same cycle of stellar evolution. The study of stars like Betelgeuse is crucial to our understanding of not just how stars live and die, but also how the materials necessary for life, such as carbon, nitrogen, and oxygen, are distributed throughout the universe. These elements, created in the cores of stars and released into space during a star's death, are fundamental to the formation of planets and the development of life. Therefore, the eventual demise of Betelgeuse, while marking the end of this particular star's life, will ultimately serve as a catalyst for new forms of creation in the universe. The end of Betelgeuse's life will also provide valuable information for astronomers studying the final stages of massive stars. One of the most intriguing aspects of these stars is how they undergo the complex process of stellar collapse. Once a star like Betelgeuse exhausts its nuclear fuel, it can no longer support its own mass, leading to a gravitational collapse of its core. This core contraction triggers the immense explosion of a supernova. The energy released during this event is vast, far greater than the star's entire lifetime of energy output. It's this release of energy that allows a supernova to briefly outshine an entire galaxy. The remnants of Betelgeuse, whether it forms a neutron star or collapses further into a black hole, will provide crucial data for understanding the physics of extremely dense objects. Neutron stars, for instance, have such intense gravitational fields that they bend space-time, offering astronomers a unique natural laboratory for studying the nature of matter under extreme conditions. On the other hand, if Betelgeuse collapses into a black hole, it will add to our understanding of these enigmatic objects, whose gravity is so strong that not even light can escape. These observations of Betelgeuse's death will help refine our knowledge of stellar life cycles, black holes, and the ultimate fate of the most massive stars. As our understanding deepens, it also informs broader questions about the formation of galaxies and the evolution of the universe itself.